Modern physicists, not theorists, and mathematicians often work in separate buildings, speaking entirely different mathematical languages. The GBP framework proposes these fields are actually observing different sides of the same geometric object. To test this, we can use the GBP Explorer app and its modular phase visualizer. The app acts as a translation engine, projecting one single geometric structure through 4 mathematical lenses. If one shape persists across all 4 disciplines, it identifies a shared architecture at the foundation of physical law. The first lens is Erwin Schrödinger's wave mechanics, which describes quantum states evolving smoothly over time. The app visualizes this evolution as a phasor, a single continuous spinning clock hand tracing a perfect circle. The second lens moves to Richard Feynman, who realized that particles don't take one path, they take every possible path simultaneously. To represent this, the app shatters that single spinning phasor into an infinite sum of competing trajectories. But Feynman's formulation left the measure undefined, the specific mathematical instruction for which of those infinite paths actually occur in reality. While quantum mechanics produces accurate results, it has relied on this unresolved selection mechanism for nearly 80 years. The third lens identifies a physical shape to fill that gap, a discrete, multidimensional toroid. This toroid enforces a rule called co-prime winding lanes. Only paths that perfectly close on themselves around a Mobius surface survive quantum interference and lock into place. This process creates a finite geometric structure, the Mach theta sum, which provides the rigorous measure Feynman was looking for. The fourth lens steps out of physics and into pure number theory. Here, the app sorts the toroid's geometric winding lanes into 2 groups based on their prime number chirality. The ratio between these 2 prime buckets mathematically converges to an exact Euler product known as Catalan's constant. The sequence is complete. Quantum paths are selected by the geometry of a toroid, which is fundamentally governed by the arithmetic of prime numbers. Continuous waves, probabilistic paths, toroids, and Catalan's constant are projections of the same underlying object. This shape is a result of a single mechanism. Time is a one-dimensional string with a tension equal to the speed of light. Space is what emerges when that string bows outward into a 3-dimensional parabola. This provides a geometric explanation for electron orbitals and zero-point energy, replacing abstract probability with the structural limits of a deflected string. Mapping this geometry allows us to manipulate atomic and molecular structures through their resonant shapes rather than just observing them. By identifying the engine inside the field, science can move from measuring probabilistic effects to performing structural engineering at the room temperature scale.